take one, the direct shear test. All right.
Okay.
Okay. So what we have here is the setup for the direct shear test, which consists of a box which can move. On this side, it has two rings which can be stacked on top of each other, and which we're going to shear like this once it's filled with sand. Once we place it in the box, we can also apply an axial load on top of the sample, and we can push the box and measure the force it takes to slide the bottom box underneath the top ring. That's how the system is going to work.
Once we are in this position, we can start operating the computer. So here, now we go to input offset, that menu over there. We're gonna reset the offset to 0 for both normal load and shear load. And then once they are in the free position, which is 0, we press OK. Well, now we can close the input offset menu and move all the way to the output functions menu. So here we're gonna just try, the next step will be to lower the normal actuator, which is the normal actuator is pretty much the piston that is on top of the sample. We are gonna bring the piston closer to the sample to a distance of at least 3 millimeters, as we can see on the picture over there, on the video over there. So here pretty much we are lowering the piston all the way, bring close to the sample, and carefully we watch until it gets closer, like just on top, about 2-3 millimeters, and then we can stop lowering the piston downward. Well, now we are gonna set the feedback control to be the normal stress, and then we are gonna adjust the set point to be 5 kPa, and then once we do that, the piston is gonna slowly lower, and then it's gonna come into contact with the sample, and it's gonna equilibrate at 5 kPa. So now we're gonna select the shear actuator control and select the shear load as the feedback sensor. We are gonna adjust the set point to be 0 Newton, and then we can pull on the shear load assembly, and the shear piston will move. So we're gonna bring the shear piston close to the sample mold assembly, and then connect the sample mold to the shear piston using the coupling. This way the sample is protected within the sample mold. Okay, now we can change the shear feedback control to be the shear displacement sensor, and then we're gonna go to the input offset screen, and then we're gonna zero the normal and shear displacement. By this way, we are in our starting position to run the test. Before we start running the test, we need to remove the pins from the sample mold. So right now we are removing them, and then we are ready to go. Now that we have removed the pins, we are officially ready to start the test. We just press run, and then the test is running right now. As we can see, numbers are changing, and then what's gonna happen, two plots are gonna show up, and then these two plots, they're gonna have the same x-axis, which is gonna be the shear deformation on the x-axis, and then on the one on the left side is going to be the shear stress with respect to the shear deformation, and then the right side is going to be the normal displacement with respect to the shear deformation. So this data is being saved, like the data that is going to be provided to you guys is the one that we just saved it from there. After you finish the test, you can just export to a personal drive, and then so now that we have already finished the test, we are going to just show how you can export the data, or you can, as I said before, you can save the data to your computer, to your personal file, to your personal drive, and then you can have different types of the different format. You can save in different ways, and also another way that you can do with this data, as we're going to show in here, you can also view as a graph. You can graph the data. You can use different parameters in order for you to save the data. As we can see here, we're going to graph just the normal the shear deformation with a normal displacement. So that's something that you guys can do as well. one of the first steps that we need to do before we remove the sample from the mold, we have to lift up the piston that is on top of the sample. We have to lift all the way up. As we can see in here right now, we are lifting slowly, we are lifting up so we can easily slide the box into the left side. So now we're just lifting all the way up. So then the other thing that we can do before we remove the sample from the mold, we can just disconnect the shear actuator from the box, and then we set that the pressure to be 0 Newton, and now we are just disconnecting. We'll disconnect the coupling for the shear actuator, and then we are going to slowly remove, and then we're going to lift it up, the top section, and then we're going to just push the box, and then we're going to see that the sample has sheared a little bit, and then that is pretty much our main goal of this lab. So thank you for watching.